Hi, I'm Stan from Ballistic Systems, and I'm going to demonstrate how to assemble the IR transmitter. It's a very small board, very simple board, but it provides the light source for the MD Basic and the MD Basic camera flash unit. So we're going to go ahead and assemble that, give you an idea how easy it is to do. So the first thing I'm going to do is I'm going to start off with the resistors, and we're going to put them into their holes. This is R1. So I go ahead and I put resistor R1 into position, and I go ahead and I spread the leads apart a little bit so it stays in the hole. And then we're going to put R3 into place, and go ahead and drop it into its hole and spread the leads apart. And then I'm going to go ahead and solder those into position. Now the solder I'm going to use I bought from Radio Shack, and it's 032 solder. It's a very fine solder. It works well for kits because it helps eliminate solder bridges because it's so small. And you notice I'm just going to put the soldering iron up against the lead and put the solder here very quickly. And it doesn't take long at all. If you apply the heat too long, you could damage the parts. And you want the part to have a nice shape of an upside down Hershey Kiss. And if it's nice and shiny and has the shape of a Hershey Kiss, then it's a good solder joint and we look good and we're ready to go to the next part. So I'm going to go ahead and trim the leads off. So all the leads have been trimmed back. And the next part I'm going to insert and solder is Q1, or the transistor. Now the transistor has a flat side to it. And if we'll flip it over here so you can see, it has a round side and a flat side. And if you notice, the drawing on the printed circuit board has a round side and a flat side. You want to match the part to the drawing on the printed circuit board. And we're going to push that all the way down, and we're going to spread the leads apart as well. Now you need to be a little careful with soldering this particular part in because this pin spacing on the leads is very, very tight. And if you're not careful as you solder, then you will get a solder bridge. And I'm going to start with the center pin first. Okay, that's good. And I'm off to one end, and we have it there. So I'm going to inspect my work, and again I have three nice Hershey Kiss shaped solder joints, and we look very good. And I'm going to go ahead and trim the leads on that as well. Now if you were to get a solder bridge, that's a place where solder has resoldered or reflowed onto an area that you don't want. You would use solder wick, which is what this material is. It's a braided copper type of wire, and you would just go to the area that you have the solder bridge on, and you would apply the wick there and just reapply heat to the solder joint, and the solder will be, as you can see here, wicked into the wick. And then that takes away the excess solder, gets rid of the solder bridge, and then all we'll do is just go back and re-solder the joint. And that's kind of what it looks like there. The next part we're going to install is R2. R2 is a potentiometer. It has a little dial on it. And because the IR transmitter is a variable output device, we use the pot, or this little trimmer capacitor, to vary the output, the light output of the infrared LED. So that goes into this position here. And it goes in there. And again, we turn it over and spread the leads apart slightly so it stays in the place on the printed circuit board. And we'll solder those into place. And like before, we'll go ahead and trim the leads. Okay, so we have the two fixed resistors here put in place. We have the transistor in place, and we have the variable or potentiometer in place. Next part we're going to put in is the red LED. Now on the LED, again, we have a round side and we have a flat side on the part. And on the printed circuit board, there's a round area and a flat area on the printed circuit board. And you need to insert that part correctly, because if you don't, it will not work correctly. So I'm going to look for the flat part on the part. And sometimes it's not a flat part, but a little notch. And on this particular part, it's a notch. So we'll go ahead and put that in, and we'll spread the leads. And I'm going to verify that I have that in correctly. I'm just going to run my thumbnail over, and I can feel the notch. The notch is right there where my thumb is. So I'll go ahead and put that in, spread the leads a little bit. And solder it into place. Now, the reason I put a red LED on the board is it gives you a visual output of what the IR LED is doing. Okay, so it gives you a reference point to see how bright the output is, and it helps you visually see what's going on. Now again, the IR infrared LED has a flat side and a round side to it as well. And we put that into the flat side there as well. And I'm going to verify that I have it in there at the flat side. And there's the flat side. So, and then I'm going to take it out. I'm going to bend it 90 degrees that way. So it looks like that. And then I'm going to hold it, and I'm going to spread the leads so they don't fall out. And I'm going to solder that into place. And sometimes when you do that, the LED doesn't lay flat, so I just bend the leads over, and that's how it looks from the side view. So we have an infrared LED, and we have a red LED that'll give you an idea of what the brightness coming out of the infrared is. And the last thing to connect in is the battery connector. And the trick to doing this is you want to come in through the top, and you want to tie an overhand knot, and we'll leave the knot loose for now. And there's a negative side or a black side. The black wire goes into the black side or negative side. So we've gone ahead and put that in there. We bend it over a little bit. And we solder that in. Trim off the lead, and we'll go ahead and insert the red or the positive side into the red wire area, and we'll bend that over a little bit so it stays in place. Okay, and the last thing I'll do is, after I trim the lead, is I will tighten the knot up. And the reason we put a knot in there is it acts as a strain release, because if you keep doing this to the wire all the time, it will break the wires on the printed circuit board. So that's why we put a knot in there. So this is now ready to use, and what I'm going to do is I'm going to go ahead and hook a battery to it. So I've hooked a battery to it, and I'm going to go ahead and turn the dial. And if you look closely, the LED is coming on and off at variable brightness.
Okay, let me get closer.
And that's how you assemble the IR transmitter. Thank you.